Hello Zimbabwe, hello South Africa, hello India, hello everyone around the world. Hope we are fine and okay. Yeah, it has been long. It's very true. And yeah, the situation in my country, everything is just down. People, they are now concentrating on buying food than fixing things. So I'm receiving very few devices on daily basis. It's not like before. So like basic jobs, fixing charging ports, screen replacement on phones. So I can't upload video replacing an LCD on a phone. Maybe I'll do one or two, but those are basic things to do, to be done by everyone. So what is in front of me? These are motherboards. I think I explained these things several times. How laptop motherboards, they are working. But from the onlook of things, when I check on the comments, people, they ask me, people, they are asking different kind of question. How do I know? How do I locate a BIOS chip on motherboard? How do I know how the 3.3 for whether this 3.3 is for the startup chip or is for the switch button, or how do I locate where the startup chip is getting the power? All those kind of things. My decoder is stuck. What to check? It's very hard to help someone over the internet, because in order to give accurate answer, I have to see the motherboard, check it myself, and then I will tell you that is the problem. So we do have some motherboards here. Half of the videos from the channel is a mess. If you go back to the old videos on the channel, the recording system, the sound quality, everything was not good during that time because of the resources. We tried to use the available resources during that particular time. So I'm trying to redo some of the things that were explained in the past. Maybe this time, those who didn't understand from the previous video, by end of this video, you'll be able to diagnose dead laptop motherboards, to check different things on motherboards, to know this is a BIOS chip, this is a MOSFET, to differentiate various kind of faults. If the motherboard is behaving that way, it must be BIOS. This is a power issue. Also such kind of things. So we have these motherboards. I don't even know whether these motherboards, they are working or not. I just take random motherboards for the purpose of learning. Okay? So previously we explained how the motherboards, they are working. I tried to draw the schematics on how I see things. And now we have some issues here. It seems as if fixing laptops is a complicated thing. People, they have infinite questions on how laptop motherboards should be fixed, how to check things, all sort of things. So what I want to do, I want to take away all the motherboards and only left with this motherboard. Let's start here. So let's get started. Yeah, when the business is slow, I think it's a good moment to learn few things. So I just taking this opportunity to learn few things to learn few things about how motherboards are working. So we do have this motherboard, which I believe is this is the Lenovo motherboard. Yeah, this looks like Lenovo. And we have this one. This looks like for HP. So we have two motherboards here, like two. So what are the common things on these two motherboards? What is common here? What do we have here which is similar on the other motherboard? Despite the fact that this is a Lenovo motherboard, this is an HP motherboard. What is common? We have some coils to represent power supply on the HP motherboard. On Lenovo, we do have same thing, coils to represent different power supplies. This is some kind of model with the processor soldered on the board. Under this heat sink, that the processor, and is soldered on the motherboard. This processor is removable. I can take out the processor outside the heat sink like this. That's the processor. That's the processor inside the socket. So this is some kind of old electronics. They were doing things smart. When they moved from this removable to this, was a disaster and a challenge. Why? Because this kind of processor is hard to replace. When you check everything, you find the processor is gone. In most cases on these motherboards, you can't do anything. That will be the end of story. So what else is common? We have some capacitors, ceramic capacitors, electrolyte capacitors, DDR3 RAM, DDR3. Everything is just same. We have the IET, ITE, that's the microcontroller. Here we have Lenovo, that's the EC chip. You see those big chips. So you have a dead laptop motherboard. The laptop came in, has no power, no sign of life, not charging, not doing anything. What is the first step? That's where we want to start. What is the first step to do on a dead laptop motherboard? The first step is to identify the charging port, because from the charging port the 19 volts is coming from the charger to the laptop. So the first step is to identify the charging port. And obviously on the charging port we have the two MOSFETs in serial mode, the current sensor, and from the current sensor, that's the VCC point of the main 19 volts power line. From that current sensor, the 19 volts is going everywhere. It's going to 3.3, it's going to 5 volts, it's going to 1 volts, 1.5 volts, all over the motherboard. So let's start by this Lenovo. Which one is the charging port here? Here. I think here is the charging port here. That's the charging port. We have big power rail, big MOSFET, small MOSFET, current sensor, and the voltage is going everywhere. What about on this one? The charging port is here, and our MOSFETs are on the other side. First MOSFET, second MOSFET, current sensor. I think we have to go on a microscope. Let's see together. Let's see together what's going on here. You see, that's the charging port. We have the charging port here, this one, and we have those MOSFET in serial mode. PQ311 and the PQ312. That is the first and second MOSFET, and that's the current sensor. This one, the black thing. The black thing here. So from the charging port, the 19 volts from the charging port is coming here. You can see the charging port here, and we have this big track which is probably going to the plus, and is coming here straight, and on the output we have a small second MOSFET. After that we have this current sensor. Let's check the other motherboard. Same thing. Same thing. First MOSFET, small MOSFET, second small, current sensor, and from this point the voltage is going everywhere. The charging port is on the other side. That's the charging port. Okay, fine. So what we have to check, on every dead motherboard, first thing is to check the charger. You check the charger, you get satisfied that the charger has got 19 volts, because the charger is working with 19 volts. So this 19 volts is going to the charging port. That's the DC in from the charger is going to the charging port. We have plus, we have minus, and on the plus we have two MOSFET in serial mode, M to the power 1, M to the power 2, and we do have the current sensor. These MOSFET, they are just switches. What they are doing in case of short circuit or under voltage, over voltage, or if anything happens on the motherboard, these switches, they are cutting down the power just to protect the whole circuit. Here we have very low ohms current sensor. I found between 0.5 ohms to around 0.9 ohms. Very low ohms current sensor. And these MOSFETs, they have 3 pins together, and the gate and 4 pins together, 3 pins together, that's the source, 4 pins drain, which is coming to another drain here, and the 3 pins, that's the source and the gate. Where this gate is going to the power management chip. In most of the laptop, that's the BQ chip. You find the BQ chip here. BQ chip. And the gate is going here. And before the current sensor, there's also a signal which is going to the BQ chip. After the current sensor, another signal is going to this BQ chip. Before the input MOSFET, there's another signal which is going to this chip. So this chip is doing a lot of job. Okay? The BQ chip. Fine. So when you plug in the charger to charging port, you have a dead laptop motherboard. You check on the input, you have 19 volts. Output 19. Output of the second MOSFET, probably you don't have any voltage. You have to understand a few things. Why this MOSFET is not driving power. Maybe we have a shorted power rail, or maybe the MOSFET is faulty, or it can be anything in electronics. So that's the input circuit. From this point, that's the VCC point. The voltage from this point is going everywhere. So if you check here, you have 19 volts. You check the output, you have 0. Check on the gate. Check on the gate. You must have voltage there. Above 19 volts, you might have 20, 21, 22, up to 25 volts. Check on the gate to see if you have a voltage there. So if you have voltage on the gate, it means the MOSFET is fine. If you don't have voltage, maybe something is wrong with the MOSFET, because you must have voltage there. So either the MOSFET will be fault, or something is wrong with the driver, which is the BQ chip. So from this point here, what do you have? We have the 2 MOSFETs. We have a switching power supply here. Switching power supply here, like 2 MOSFETs, and those MOSFETs, we have the high side and the low side MOSFET. The high side is connected to the 19 volts. The low side, the other side, is connected to ground. And all these MOSFET, the gates, they are going to the BQ chip. And on the output here, we have electrolyte capacitor. We have coil electrolyte capacitor, and that the power to charge the battery. We have the B minus and B plus to charge the battery, and the power from the battery is coming this direction. We have MOSFET here, and this MOSFET is going straight to the VCC, and from this is going everywhere. So the power from the charger is coming this way to the battery, and from the battery is going this way. So basically, only 90% of the motherboards, that's how the input circuit works. So I don't see anything problem here. If you don't have 19 volts, try to understand why these MOSFETs, they are not passing voltage from this end to the current sensor. Either the MOSFETs are fault, can be a reason, or we have a shorted main 19 volts power rail, or the BQ chip can be fault. On the BQ chip, what we are checking on the BQ chip, you check the V in. V in, you must have 19 volts going to this chip. If you have 19 volts going to the chip, what is the next step? The next step is to check if this pin, if this chip has got voltage on pin number 6, that the AC detect pin. We must have voltage that is around above 0.6 volts there. Any voltage that is above 0.6 volts to up to 3 volts. I found in many laptops this voltage is stretching from 0.6 to around 3 volts, close to 3 volts. So if you see something like that, probably the BQ chip is okay, and we have other issues. So that is the first step on diagnosing laptop motherboards. Try to understand the input circuit, because 90% of the problem they come from this power supply, the main 19 volts power rail, if not the 3.3. Okay, so let's see what do we have here on this. We are trying to combine theory and practical so that you understand what I'm trying to say here. Let's go. That's the input circuit. You see, we have the DC in. It's written. This board is smart for Lenovo. Everything is written on the board. We have the DC in jack. First MOSFET, second that's the current sensor, and where's the BQ chip? Where's the BQ chip? What is the BQ chip here? Yeah, that's the one. How do I see? How can I do it for you to see? That's the BQ chip. So let's connect the power supply and start checking things. Let's connect the power supply. We want to see what's going on here. So what I will do, I'll stick one probe on the plus. Okay. What do you have on the BQ chip? We have nothing on this chip. So I don't think this is a working motherboard. Or let's test one more time, because we have to understand why. No, this board is not good. This board is not good. What I'm doing here, I'm trying to put 19 volts on this motherboard. Yes, the ground is connected. Let's connect the plus. And why? Okay. Now it's not working. Now it's not working. So here you can see on the screen, on the DC we have 19. And on the MOSFET we do have 19. So on the output 0, on the input 19. Current sensor 0. So exactly what I told you. In our case, the first MOSFET is not driving power. So why the first MOSFET is not driving power? We are not here to fix, but we are here to learn why this first MOSFET is not driving 19 volts. Why? Let's check again. Let's check again. That's the input of the first MOSFET. The output 0. Okay. You know what? Let's lower the voltage to 5 volts. Let's go on the output. Now you understand? We set voltage to 5.9 volts, and I'm injecting 5 volts on the current sensor, and it's taking 3.5 amps. So this is a shorted motherboard. For now, we now know this motherboard, no matter how you can do it, it won't turn on because the main 19 volts power line is shorted. But to confirm that, let's put the multimeter on diode mode. Let's check this capacitor. 0. This capacitor 0. 0. More capacitors 0. Here we have another capacitors 0. So this board is not turning on. Actually, this board won't turn on. We have found that the 19 volts is not passing the first MOSFET because of a short. So exactly that's what is happening here. This MOSFET M1, this MOSFET is cutting down the power. Why? Because of a shorted motherboard. Let's check those MOSFETs. Drain to source. The MOSFET is good. The smaller one, is shorted. But this is the second fault. Even if you take out the second MOSFET, I'm 100% sure we will still remain with a shorted main 19 volts power line. I'm 100% sure about that. I am 100% sure. What is taking this power? Where's my controller? I'm trying to understand what is taking this power. 3.5 amps. I can't see anything getting what? 4.3 amps. Okay, we are doing experiments here, so it's good to see what is shorted on this motherboard. It's very good to see. We do have all-in-one processor with graphics and PCH together. The graphic chip and PCH is inside this processor. So it's very possible to have like a dead processor here. It's very possible. So let's see. What about my E.T.C chip? Because 4.3 is not a joke. 4.3 amps. Something is consuming that power. The processor is just getting warm. Okay. So this is a faulty board. Let's just check other things. So we know the main 19 volts power line is shorted. Let me tell you a trick. If you get something like this, you are fixing motherboards, you don't want to waste time. Check, try to locate the BIOS chip. Try to locate whatever BIOS chip is on that motherboard and check pin number 8. In most cases, you spend hours and you realize that the VCC pin is shorted to ground. And mostly, if pin number 8 is shorted to ground, maybe that 3.3 is going to the PCH, and the PCH is inside the processor. You see bad news. So pin number 8, this is pin number 4. Pin number 8 is not grounded. Coils 0 0 0 0. Okay. In our case, the last pin is not beeping to ground. Zero 0. We have the capacitors around the EC chip which are beeping, so we have to come with 3.3 there. I'm sure the EC chip is gone. I'm 100% sure. We need alcohol. Where's my alcohol? We need alcohol. 1 second. Let's see. So checking on the capacitors around the EC chip. Around the EC chip. We have this chip. This is Lenovo. We have this chip. So you can't see the test meter, but you hear the sound. Check this capacitor. 0 0. And here this one is shorted. Here we have more capacitors here. 0 0. You see those capacitors here are shorted. We have a problem there. We have a problem. So I want to come with the 3.3. We just want to understand how we should deal with the various kind of faults. So 3.6 amps. Let's come with power, and it's taking 1.8. Yeah, the EC chip is gone. The EC chip is gone. Trust me. It is gone. It is gone. Let's go on a microscope together. Let's go on a microscope. I will inject 3.3 on those capacitors. 3.3. Check what's going on here. You see? This is a sign of a dead EC chip. So this EC chip is dead. This is a dead E.C chip. So what we know by now, the E.C chip is dead. The E.C chip is dead, and the main 19 volts is shorted. So let's take out this E.C chip. We are not fixing. We want to see what kind of faults do we have here. So let's take out this big chip. This is an experiment. Yeah, the board is still sucking the heat. So we have to be patient a little bit. That the chip is out. So the question is, do you still have short on those capacitors? No, you can see it's not beeping anymore. So this chip is gone. That is the problem with this motherboard. And the main 19 volts is still shorted to ground. So this board has got many faults. It has got too many faults. And I don't think the processor is in a good state. I don't think so. I don't think so. Anyway, so if you are to find out what is the problem, it's not worth to try to find out what is shorted. Maybe it's a capacitor, maybe it's a MOSFET. We didn't check properly. But that's not the idea. The idea is how you are starting the job until the moment you find the fault. That's the main part that we need to focus on. The process of fault finding. Because it seems that is the major problem with many technicians. How you are getting to the problem. The fixing part, that doesn't matter. You have to skip because everyone knows how to replace a MOSFET, how to replace a capacitor, but not everyone knows how to find a bad cap or a bad MOSFET. The sequence It's not easy for everyone. So let's take another motherboard. We have this motherboard. Yeah, this is some kind of old vintage motherboard. This looks like it's a, what is this? This is a Samsung motherboard. Samsung RV510. Yes, RV510. Samsung motherboard. I still remember fixing such kind of motherboard. We have the processor, we have the graphic chip under heatsink, we have the PCH, some power supplies. That's the charging port. The common fault with this model of motherboard, the charging port. Check what is inside this charging port. Maybe you can see we have two wires separate. The plastic thing just broke inside the charging port, and what I'm doing, I'll modify and put an SI charging port. I'll take out the wall charging port, I'll modify it and put a different charging port if I don't have. That is the common fault on this. We have SMSC, that's the EC chip. Winbond, that's the BIOS. Okay. So we have to check, is this a working motherboard or not? Is this a working motherboard or is it a dead motherboard? Which one is the plus? 19. And we have a light. Check the light here. Maybe you can see. This is a working motherboard. We have this light. You see the light? That light. So that light, it tells us more that the 19 volts is okay. 3.3 okay. Okay. Volts 3.21. The 3.3 is okay. What about 19? The 19 volts is present, you can see. So 3.3, I remember here is the connector going to the switch button. Here we must have 3.3 on this board, and the board just started. Check the current. It's taking 600 milliamps, and now we have two lights here. You see, we have the blue and the orange light. So this is a good motherboard. This is a good one. This is a good one. Another motherboard here. What is this one? This looks like an Acer motherboard. Yeah, it is for Acer. This is an Acer motherboard. Plus I think that the current sensor here. So just take this power supply as your charger. You have plugged the charger, the board is not turning on. What is the next step? What is the next step? Plug in the charger, the laptop is not turning on. The first step, check the 19 volts. check the 19 volts to see if the MOSFETs they are driving the power. Here we have 19, here 19, 19. Okay. Let's check what we have on the other side of the board. This one, it seems as if the 19 volts is okay. What do we have here? We have 5 volts. We have 3.4. Okay. So the 5 volts and 3.3 is present on the ENE chip. 3.41. You can see on the screen. So if you check the 19 volts is present, you check the 3.3 volts is present, it means the board is ready to be powered on. Because from this 19 volts here, from here, the 3.3 volts is coming from the VCC point. It's coming from the VCC point. We have the VCC here, 19 volts, VCC point here. From here we have a power supply with 2 MOSFETs, the high side and the low side, which is connected to ground. We do have the driver. The gates are going here. That's the driver. And what this driver is doing is handling 2 power supplies. Because here we have a coil, electrolyte capacitor, and that's the output for 5 volts. On the other side, what this coil, this chip is doing, we have 2 MOSFETs. This one connected to ground. Here we have coil on the output, electrolyte capacitor, and we have 3.3 volts. All this is being managed by one chip. This chip can be 1225C, 51225C, 51125C. Can be, you find different kind of chips. Can be RT8205, so many kind of chips. So the 19 volts is coming to this power supply, which looks like a dual power supply, but it's not. It's not. You have ceramic capacitors. Can be 2, can be 3 ceramic capacitors connected to ground. The other side is connected to 19, the other side is connected to ground. We have one output here. We have the second output. And if you check on the chip, one second, let's go on desktop. No, TPS 5112. I found something. Yeah, we have this this power supply. This is TPS 51123A. And what I'm trying to say here, edit. No, I can't edit. How do I edit this one? Open with. Yeah, now better. Now looks better. Now looks better. So we have these 5 volts. 5 volts. Okay. We have these 5 volts here. That's the first output. On the other side, we have 3.3. Let's call it 1. Here 2. You see this? And if you check straight on the chip, we have a VREG 3. Which one is the VREG 3 here? VREG 3, 1 second. VREG 3. Here. Oh, they put these signals together. We have the VREG 3 and VREG 5. So here, you see here, this signal, 3.3. From this signal, our SIO chip or a startup chip is getting power. From this signal, the VREG 3 is not getting power from this 3.3, but it's getting from the VREG 3. And here we have the 4th signal here, VREG 5. So this chip, this power supply is like, it looks like it's a dual power supply, but it's not, because it's managing 4 voltages here, 4 outputs. We have this and this, and we have these other 2, and these are very low output power supply. I think it's around a very low current, around 0. You can see here it's around 0.0, around 100 milliamps, 100 to 300 milliamps. These power supplies, low current output, true. So that's how the 3.3 volts power supply is working. And after that, new we have the BIOS chip. A BIOS chip is very easy. We have this chip, that's the chip with 4 legs, win bond. That's win bond. We have pin number 1. You see a dot here. That's pin number 1. Pin number 2, 3, 4, 5 here, 6, 7, 8. So pin number 1 is corresponding to pin number 8. Pin number 4 is ground. This pin is connected to ground. And pin number 8, that's the VCC. So from this pin, on most of the BIOS chip is going to the startup chip. It's going straight away to the startup chip. So after checking the 19 volts, the input section, you are satisfied everything is okay. The next step is to go to the 3.3 volts power supply. Because this is the 3.3 volts is always on. Always on, even if the laptop is off. There is voltage there. So 99% of the problems, they are from this power supply. Trust me. 99% of the problems, they are from this power supply. Because if everything happens that we have a fault motherboard, check these two power supplies, the 19 volts and the 3.3. With this, just knowing these two power supply, you can fix 90% of the laptops. Of course, we have other things like the RAM power supply. You can find a fault RAM power supply, fault GPU power supply. The vehicle power supply for the processor can be faulty. But if this power supply, if there's power supply to die first, this one will die first because it's always on. And bad things can happen on this power supply. So that's how motherboards they are working, from the 19 volts to the power supplies. And what these power supplies, if you check every power supply, you have two MOSFETs, you have ceramic capacitors to prevent the spikes, you have the driver, that's the regulator of the power supply, which is inputting high voltage, which is 19, and outputting lower voltage, either it's 5 volts or 3.3 or it's 1 volt for the processor or for the GPU. So what we need to explain further is about the BIOS chip. What is a BIOS chip? What is a BIOS chip? It is a chip. BIOS chip. Built-in OS or basic input output. What does BIOS stand for? 1 second. We need to know the abbreviation BIOS stand for what? BIOS. Stands for Basic Input Output System. Basic Input Output System is the program a computer's microprocessor used to start the computer system. So that's the BIOS chip, Basic Input Output System. This BIOS chip is containing a firmware, and what that firmware is for the startup sequence of the laptop. When you press the power on button, the BIOS settings, they are obtained from the BIOS chip, because this BIOS chip is communicating with the E.C chip on how to run the program when you press the power on button. So let's see let's see, where's the BIOS chip here? Because, you know, one of my subscribers was asking me how to identify the BIOS chip. I'll show you. I'm about to show you now how to identify the BIOS chip. So I'll take out one BIOS chip from this board. I'm taking out the BIOS chip because you have to know and this BIOS chip on motherboards you find either one or two BIOS chip, but they are doing some. They are the BIOS for the E.T.C chip. You can get the BIOS for the PCH. I took out the BIOS. I need to also to take out MOSFET. Just a random MOSFET. Okay. Let's compare a BIOS chip and a MOSFET. Do you think we can do that? We have these two chips. How to make this clear? Good. You see those chips? I think it's now clear. So, which one is the BIOS chip and which one is the MOSFET? Huh? Which one is the BIOS chip and which one is the MOSFET? Over this smaller one is the MOSFET, and this bigger chip, that's the BIOS. So that's how you identify a BIOS chip on a motherboard. It is a MOSFET, but an extraordinary MOSFET, let's say so. It looks like a MOSFET, but it's big in size. That's a BIOS chip. Because all they have 8 legs, but this one, so we have a dot here. We have a dot here, pin number 1, 2, 3, pin number 4 is ground. 5, 6, 7, 8. Pin which is opposite to the dot is pin number 8. That's the VCC pin. That's the VCC pin. So that's the story about the BIOS chips. That's the story about the BIOS chip. Someone was asking me how to locate the BIOS chip. Someone was asking me. Let's see. Here, we are on the comment section on the channel. And I would like to thank the subscribers. The channel is growing. Now we see 1.860 subscribers, 250 videos. I think you are learning something from these videos. Yeah, just from any African technician, what we can do. So let's go here on the comment section. Where in Uganda can Can this queue be learned? Huh? I'm not in Rwanda, my friend. I'm in Zimbabwe. And these skills, you don't learn them from school. You don't learn electronics from school. You have to do it at your own. That's how you get things. You learn faster. If you are looking for a college degree, probably you are just looking for a place to waste time and resources. Otherwise, you have to do it at your own. Huh? So, yeah, check this comment. How do I find the BIOS on my own laptop? Check a MOSFET, which is big in size. A chip like a MOSFET, which is big in size. On any motherboard, you find 1 or 2. That's a BIOS chip. I'm slightly confused. Some explanations seem to indicate the separate 3.3 supply direct into the SO or BIOS, then 3.3 and 5 volts separate. Could that be true? Or say SIO and BIOS definitely powered from 3.3 and 5 volts. Okay. So I think I explained about this. If you come here, where's that? Let's go to the desktop. If you come here, you see this. We have 4 outputs here. We have this output. We have this. We have the VREC 3 and VREC 5. So the SIO chip is not, the SIO or the startup chip is not getting power from this output. It's getting power from this VREC 3. If you check with the test meter from this point, the startup chip is getting power from this 3.3 volts. It's getting power. So don't get this confusion of being confused what this power supply is really doing. This is 3.3 volts. Probably this 3.3 volts is going to the PCH, is going to the screen, because on the screen we have 3.3 volts there. We have 3.3 volts which are there to adjust brightness, and those signals, they are interlinked with the startup chip again. So don't get this confusion. Don't get this confusion, because the 3.3 always on is coming from the VREC 3 of the driver. Yeah, kindly help me with my decoder. It's not working and showing green light, and it can not be switched off and on. You know, the kind of decoders, especially the open view, when you see green light and it's not changing, you know what the problem? In most cases, check the processor. You check the processor power supply. In most cases that power supply is shorted to ground, and the processor is gone, and you can't do anything. My Connect Slim L1470 is stuck on enter password. I cannot even restart it. If it is stuck on enter password, Can be many things. Maybe we have a hard drive issue. Maybe we have a BIOS issue. Can be anything. Try to check along those lines. So, yeah. I was just attending to some of the comments. So, that's how motherboards they are working. That's how the BIOS chip is working. And on the screen side, is very easy. We have 19 volts to power on the screen. We have 3.3 volts. And we have those, which is going to those two signals. The one is PW, the power management, and the other one is the LED on. LED on is to adjust brightness and to power on the screen. That's what you can check on the power sequence which is going to the screen. Check if you have 19 volts or if you have a 3.3. I found this problem mostly if you have backlights problem on a laptop. Check these signals. Check either we have 19 volts. If the 19 volts is present, I'm sure if you check on the screen panel, we have some test points there. LED on, and the other one written PWM or BL. You find different writings there, but there are signals to adjust brightness and to power on the screen. So that was the issue about the motherboards, because many people, they are asking me every day. Some even on WhatsApp. Let me show you. Some even on WhatsApp. I have this message, you see? This is WhatsApp. And this is one of my subscribers, which is I'm doing good. I'm facing a big challenge with one of the laptop. I changed many screen and RAM, but not displaying anything. You change the RAM, the laptop is not displaying. You change the screen, the laptop is not displaying. Check other things. Because the causes of no display, there are too many. You can't focus on two things. What you have to check more? Did you try to reflash the BIOS? You can try to reflash the BIOS. Maybe you have a BIOS issue. If the BIOS is corrupt, the firmware from the BIOS chip, because I never found like a dead BIOS chip, but the firmware inside the BIOS can be corrupt. So try to reload the firmware. That can be a reason. Check the RAM power supply. Do you have voltage on the RAM power supply? Maybe you have a fault RAM power supply, or the GPU. What kind of motherboard? Maybe it's maybe the graphics chip is fault. Maybe if it's some kind of, because it didn't send like a proper picture, so I can't see from this, but this looks like it's an old type of motherboard, because I can see some RAM memory chips here. That's the memory for the RAM. What about that's the memory for for the graphic chip. Try to check other things. Maybe we have a faulty graphic chip. Maybe it's BIOS. Maybe the RAM power supply is faulty. The GPU power supply is faulty. Maybe we have other problems. So don't focus on two things. You check the RAM, you check the screen. Fine. Go and check other things. The problem, I can't help someone over the internet. That's the problem. Because most of the people think that I can help them over the phone. It's very impossible. Because I have to check things on my own and see, here's the problem. But if you send something over WhatsApp or over internet, it's hard to help you. It's hard. But check other things. Check the GPU voltage. Check the RAM voltage. Try with a different firmware from the BIOS chip. I'm sure there must be a BIOS there. Try to reload the firmware from the BIOS chip. So that was the story about motherboards. That was the story about motherboards. This is another Acer motherboard. 2 MOSFETs in serial mode. Those ceramic capacitors in parallel mode. Okay. We have ENE. We have WinBond, that's the BIOS. We have the processor. This is some kind of processor under this heat sink. This processor is removable. We have the PCH here. We have another BIOS. You see, this board has got 2 BIOS chips. We have this BIOS chip and this BIOS chip. So probably maybe this one is for the PCH because it's close to PCH. So the motherboards, nothing is hard on fixing motherboards. Focus on what you know. Obvious, from the charging port, you are checking the charger first. If the charger is good, check if the 19 volts is passing those 2 MOSFETs. If there's any problem on the motherboard, in most cases, the 19 volts is not passing those 2 MOSFETs. But those 2 MOSFETs, they are like gates. Those are the main gates for the motherboards. Because in order for 19 volts to pass these 2 MOSFETs, everything must be right. So if you have 19, so if you have 19 volts, you have 3.3 volts, you try to turn on the motherboard, it's not responding. You know, that's where the complex of repairs starts. You have all the voltage, the motherboard is not turning on. Check the power button. Because the way how the power button is working, a power button is a switch. It is a switch. A power button is a switch. So we have a power button like this. And here is connected to ground. This is ground. This is the 3.3 volts, which is coming. Maybe we have some resistors here in serial mode, and it's coming straight from the E.T.C chip. This startup, this signal, which is going to the switch, the 3.3, is coming straight from the E.T.C chip, startup chip. So the condition for the laptop to start, this 3.3 has to be shorted to ground. If you press the power, this 3.3 is moving to ground and release. So if you press this, the power on button, check with the multimeter to see if that 3.3 is going to 0. When you release, it go back to 3.3. Pressing, it goes to 0. If you see something like that and the laptop is not coming on, probably the E.C chip is gone. That is another way to check. That is another way to check. Or you can check with the charger. Check with the charger. You have 19, you have 3.3. Check to see if you have charging light. You press the power on button, it's not turning on. Check to see if you have charging light. If you have charging light, maybe you have a different issue. But if you don't have charging light, you pressing the 3.3 is going to 0. You don't know charging light. 100% sure this chip is gone, will be gone. But if you have charging light, check other things. Check the 5 volts, check the voltage for the vehicle processor, for the GPU, and the other voltages. Because any fault can give us bad result on turning on the motherboard. So check other things. Check other things. So let's see if we still have some comments to reply from the channel. Let's see. My open view, what we explain this with the 2 BIOS chip. How do I know which one to use? Is the BIOS chip always located near the E.N.E chip? No, the BIOS chip is not always located close to the startup chip. Can be far. That's not important. And how do I know which one is the BIOS to choose? I think this one we need a practical example. Let's see which board has got 2 BIOS chips here, so that we try to separate the two. BIOS chips. Where's the BIOS chip for this one? Let's focus on the ESA. Yeah, the ESA problem, the ESA is obvious. The BIOS chip is close to the E.N.E chip. And we have another BIOS chip here. Probably this one is for the backup. But what I'm doing on the BIOS chip, you find some writing on the BIOS chip. For example, Winbond BIOS chip, you find 25Q32. You find a BIOS chip Winbond written this number 25Q32, and the other one 25Q64 on the same motherboard. In most cases, this one is the main BIOS chip. This one 25Q64, that's the main BIOS chip, and this one is for backup. You see this main BIOS chip inside the box. This one probably for the backup is not inside the box. Yeah, this is like some kind of confusion on the new models of laptops, motherboards. is like bringing confusion on repairs. You see the laptop maybe is coming on and goes off. You think of reflashing the BIOS chip. You don't know which BIOS chip to choose. Start with this one, the main one. Or you can take out both BIOS chip. You test with the programmer. The one with bigger size, that's the main BIOS chip. Because obviously this BIOS chip, they are of same size. They are of different size. This one can be 16 megabit BIOS chip. And the other one can be of low value. Can be of low value. Can be, this one can be 16 megabytes, 8 megabytes BIOS. And the one for backup usually is 2 megabytes or less value. That's the way how you can separate the things. So what did we skip to explain here? What did we skip to explain? What liquid do you use when you are checking for heat on MOSFETs? I'm using isopropyl alcohol. I bought it on AliExpress. It's very cheap. Before I was using thinners. You can use thinners if you don't have. You can use. I don't recommend the spirit. I don't recommend using spirit because the spirit, the rate of evaporation is very low. So if you test the body fast, bad things can happen. As compared to isopropyl alcohol, which evaporates very fast. So yeah, I can see on the OBS is now an hour and a half explaining how motherboard works. Hopefully I will upload many videos on repairs. The problem these days, everything is very down. I can't upload videos like before. I posted that I'm going to upload many videos on cell phone repairs, but the thing, I can't get those jobs. I'm getting silly jobs like charging ports, LCDs, and I can't upload videos, something like that. Because the idea is for someone to learn something. I'm sure we are not on different level. Some they fix motherboards with the schematics. Some they are on the beginner side. And I'm trying to share what I know on motherboards. I'm not a teacher, but I'm trying just to share what I know on laptop motherboards. So yeah, just have a nice Sunday. Don't forget to share our videos to your beloved friends and relatives. Also like, comment and share, please. And see you on the next one. Bye.